Let us pray, members.
Please go on with the prayer.
Yes, I'm praying. Lord, we thank you for this moment. We thank you for whatever we are going to learn. We thank you that you have provided this platform for us to study. Thank you, Jesus Christ. In the mighty name of Jesus, I believed.
Amen.
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 Was that Prosper? Okay, I want to thank you for the word of prayer. I want to welcome each one of you to this day's lesson or discussion. The success of our discussion depends so much on our discipline. And may I request that each one of you mute their microphone, even their video. May I request that you each mute your microphone and also mute your video so that we can hear from each one of us when time comes. If you don't mute, then we shall not be able to communicate. And that discipline is very important for the success of our discussion, whatever the discussion is. So I request that you mute both your audio and video. I can see people's video. Please mute your videos as well, so that we can.
Okay, please, people,
We shall give you.
And start.
We shall give you time.
People mute, then we start, please.
You will get an opportunity to put on your video, but can you switch it off now? So that it is easier for us to communicate. Okay? Okay, thank you very much. I want to welcome each one of you at this afternoon's discussion. Okay, just a minute.
Please, people, you mute, then we start. Please. Panang.
Okay, I'm sorry, but I had to mute all of you. I hope you can now hear me. I have just said that if we are to discuss and succeed in our discussion, then we need to behave. This discipline is paramount. And one form of discipline is the maintaining order. And one of the ways is to keep quiet. Keeping quiet requires that you mute your microphone so that we can hear from each other when you come in and make noise with your microphone, if you make noise, some of you, your backgrounds are noisy, then we shall not succeed in what we are doing. I want to thank everyone who has made an effort, and I want us to start. We have already had a word of prayer. We have thanked for this platform, and I'm really very grateful that we have a chance provided by help and help administration. Mr. Dungu and Mr. Kaziba, thank you very much for connecting us and providing this platform so that we can have this sharing with our candidates. It is very important that we do practice. Mathematics just mainly requires that we practice. Otherwise, you have done everything. If you do not practice, you will not be flexible, you will not enjoy. So keep practicing. This afternoon, we thought that we could get some work for us and practice with you. We have already shared this work with you. I hope everyone has a copy of the same work. But if you do not have it, then I can provide the questions here where we got them. You're going to be a little patient so that I share with you the questions. The first question in section A, if we are to start with section A, our first question is the trigonometric question. And let me share the play. Okay. I think you can now get the questions as I have shared them. Number one, as I said, is trigonometry. And it is giving us those questions, the equation, which our duty is just to solve the equation, the trigonometrical equation. I shared these questions, I requested Mr. Kaziba to share these questions so that when we come, everyone has an idea and can discuss. By show of hands, may I see those who have looked at number one, and if you have an idea of what we should do, or if you want to discuss for us, please put up your hand and we see the way to go. Natkunda, let me see if you can unmute. Natkunda, please unmute.
Okay, can you hear me?
Natkunda, go ahead, please. Go ahead.
I think for number one, we can change the 3 cos 4 theta and change it to in terms of cos of 2 theta. Like we make the cos of 4 theta into, like we break it down using double angle formula. So I think we would take 2 cos squared of 2 theta minus 1, then we substitute it where there is the cos 4 theta. Then we'd have a quadratic equation which we can solve.
Okay. Thank you very much. May I write? Or you are ready to write for us?
You can write.
Okay, Natkunda. Let me write.
Thank you.
Okay. Let me share the question here. where, and then we see how to go about the question. Are you seeing my screen? If you are seeing the question, the screen that I've shared, may I see your hand up, please? Those who can see the question. Okay. Amla Jojo. Amla Jojo, you can unmute and talk to us just. Amla, is it clear? Amla disappears. Mutesi, unmute and talk to us.
Yes, teacher, it's clear.
It's clear. Can we use that? You can now put down your hands. Then we can go ahead. I would want to share with you when you can unmute and say what you want and then mute. Though as we started, there was a lot of noise. So I will unmute you after a short while, but let's start with that. We have been guided by Natkunda, who told us that we can go ahead and Natkunda told us that we can go ahead and break down using double angle formula. Using the double angle formula, Natkunda says we can break down the cos of 4 theta to 2 cos squared 2 theta minus 1, and then we shall come up with a quadratic equation. I hope that is what she said. Cos of 2 theta, and this is equal to 0. Okay? When you open those brackets, you will notice that you will have, and reorganize, we shall get 6. Then we shall have cos squared 2 theta, and we shall get 7 cos theta, cos 2 theta, and we shall subtract the 3, which is actually equal to 0. This gives us a quadratic in cos of 2 theta, which we can work out. Jojo, and you can unmute.
Oh, so I'll just clarify about the 3, but I've seen it.
But it is?
It's okay, I've seen it, the 3.
Okay, so we can continue. Yes, Prosper,
Yeah.
you can unmute.
So according there, can we relate or
Please go ahead. What? I didn't hear you.
accordingly, can we late on that part?
Oh.
Yeah.
It is comfortable if that is what you are happy with. But you can even work out with, you can work this out the way it is. You can already see that this is a quadratic in cos, and continue with it that way. But if you are uncomfortable and you would want to let, no problem.
Because
but at this stage, you should be comfortable, Prosper.
okay.
So go ahead,
Okay, so
look at the coefficient of the squared term and also the constant term, multiply them, which gives us 6 multiplied by -3. Those are factors. That is -18. Look for the factors of -18 or factors of 18, which when added, -18, which when added will give us 7. I usually love to list down all the factors so that I give an opportunity to look at all of them. They are usually not very many. 1 and 18, Then we have 2 and 9. And we also have 3 and 6. I think those are the factors. Do we have any others? 4, no. 5, no. Then 63 is going back to the factors that we have. So can you pick a pair that adds up to give us 7? Can you pick a pair adding up to give us 7? Yes. Are you looking at them? Anyone to guide? Is there anyone? Yeah. On Dravu SS, who is behind there, you can unmute. Or Dravu.
Yeah, the factors there, I think they are 9 and -2.
Very good. 9 and -2. So go ahead and break down our 7 into those two. You have a 6 cos of cos squared of 2 theta. Then you have a 9, which is actually a positive 9. The cos of theta, 2 theta. And you have to take away 2 cos of 2 theta. Then take away 3. Which is actually equal to 0. Take away 3. Which is equal to 0. Which equals to 0. Okay? Pair them. You will have the first pair and look for factors of that one, common factors. Then you have the second pair, look for the common factors. So when you look at the first pair, common factors are what? We have 3 cos of 2 theta being your common factor. Pull it out. What do you remain with? The 2 cos of 2 theta plus 3. And also the 2 cos of 2 theta plus 3. And also -1, leaving you with the same 2 cos of 2 theta. Take out, add 3. Which is equal to 0. So when you factor out the 2 cos of 2 theta plus 3, it leaves you with 3 cos of 2 theta, 3 cos of 2 theta minus 1, which is actually equal to 0. Okay. Go ahead. We have either from the first bracket, either the cos of 2 theta is -3 over 2, or the cos of 2 theta is 1 over 3. I would expect that you come up with our quadrants at that level. In the first place, we know very well that the cosine of any angle lies between we know very well that the cosine of one angle lies between -1 and 1. And so that tells us that we don't have any value, any values of theta that will satisfy the equation where cos of 2 theta is equal to -3 over 2. So it leaves us with one option where our cos is positive, and we shall have an angle there, and we shall also have an angle in the fourth quadrant, because those are the quadrants where our cosine is positive. So we shall have an angle in this quadrant. If I may ask those who have calculators, give me the cos inverse of a third, because 2 theta should be the cos inverse of a third. So someone to give me the cos inverse of a third. Give me the cos inverse of a third. Oh, yes, Prosper, please go ahead. What is the cos inverse?
Cos inverse of a third, it is 70.52, then and some other values.
70.52. Have you rounded off to 2 places, or you
No, okay.
just...
If I round off, it is 70.53.
Yes, it's important. Wherever you stop, you round off.
Hey. Okay,
So
I have a question.
if you have chosen 2 places of decimal, please round off there. 70.53. My workload is not... Yes, please go ahead.
So the question was, in paper 1, are we advisable to... Are you hearing me?
I can hear you. Please go ahead.
In paper 2, is it advisable to give the answer to 4 decimal places, or?
Usually for an angle at any level and in
Yeah.
any paper,
Yeah.
in any paper, one place of decimal is enough. So whoever can give, if you can give 1, comfortable. If you can give 2, comfortable. If you give 3, and you can give as many as you want. But from
okay.
1, that
Thank
is
you, sir.
Okay, so if I have those as my angles, what is the first angle in the first quadrant? Our first angle is going to be 70.53, not so? That is an angle whose cos inverse is a third. What is the second angle? The second angle will be measured from here until that point. And what angle is that? Please give me the angle. What angle is that when you measure up? Winnie, please unmute and go on. Yes?
It's 289.47.
289.47. Thank you. 289.47. Thank you very much, Winnie. So that means that since our original, since our question gave us the range from 0 to 180, our 2 theta therefore can be from 0 to 360. I hope everyone is comfortable. If our theta is between 0 and 300 and 180, when you multiply by 2, you get that 2 theta lies between 0 and 360. That is our 2 theta. So those two angles are the ones that are in that range. Go ahead and divide it through by 2 and you will get the values of theta. So what is our theta? Our theta will be divided by 2. What will that give to us? Please divide. You can see the 35. 35 point, yes, Winnie?
For the first angle, it is 35.27.
27 what? You have rounded off?
Yeah, I've rounded off.
Leave it as it is, 35.2.
35.265.
265. Then the second one is?
144.74.
0.7.
4.
2 what? 7335. That's all?
Yes.
0.735. So when you go ahead, you will notice that therefore, our theta, since we have been working with the 2 places of decimal at this point, I don't expect our answer to be correct to 2 places of decimal. So our final answer, we shall round it off to 1 place. If you want to give 2 places of decimal, then work with more than 2 so that you can round off to 2. So we have already been working with the 2, then round off our final answer to 1 place. So when I round off our final answer at 1 place, I get 35 point what? 35.3. That's why I didn't want you to round off, because I want to round off at once. This is 144.73, so that would be 0.7 degrees. So those become our answers between 0 and 300 and between 0 and 180. I thank you. Do we have any comments? Would you want to say something about this? Okay, do we go ahead? No challenges? I can share the second question if there are people who do not have it. I can share the second question if you don't have it. Okay. Yes, Winnie.
What I'm asking, like we haven't looked at the other side of the -3/2, whereby we are having the course being in the negative quadrant.
Oh, I talked about it and I said that the cosine of an angle ranges between -1 and 1. This particular value is -3/2. Can you try and find out the cos inverse of -3/2? Maybe that will guide us. Winnie? What does your calculator give?
Yes, I think, let me see, cos inverse 3. Math error.
Very good.
Yeah.
What is the interpretation for that? How do you interpret it? Why is it giving us math error? Or what is the meaning
of the maximum, whatever, of course, is always a 1.
Very good. So we looked at it, but we said that it doesn't carry meaning because the maximum is -1. So you don't have an angle that is having a cosine that is more than what? That is more than negative, or that is less than -1. So that was the reason for that other side. Not that we didn't consider the side, we actually considered it, but it wasn't giving us any angle. Is there anything else that you would
No,
want to
Master.
comment about?
No,
You will come.
thank you.
Okay, thank you. Thank you very much. If there are no other challenges, yes, anyone else? No, that is still Winnie. Is that, no, there's another hand up. Techno? Yes, please open your mic and talk to us. Hello? Are
It's
you there?
just if I don't have any other question, just a
No,
friend
there's
is
someone
raising
here with a
hand.
hand up. Open your mic. Someone using
Okay.
Techno? Yes.
Okay,
please.
sir. This is Prosper speaking.
Oh, Prosper, yes.
So I'm requesting to see how the answer was, because I didn't understand the other part where the signs change, whereby we use this sign, the thing of all here have all signs positive, here have negative, that part, eh?
Prosper, did I get you? Prosper, what did we have?
As the
This other
answer,
part for negative angles,
yes.
we would have had it in the two quadrants where cosine is negative.
Mm,
But our argument was
yeah.
that because it is negative 3 out of 2, it
Yeah.
is out of the range of acceptable cosines of angles. Cosines of angles range between -1 and +1. And this is far less than the -1. It is -1.5, less than the -1. And so there is no cosine of angle in that range. When I asked Winnie, I thought you would also do the same because I asked her to go to the calculator and get that cosine inverse, where she told us that the calculator is not giving any particular value, but instead is giving a what? Is giving
A math error.
a math error. So it is not that we just left it out, no, but it does not carry any meaning. If it had been in the acceptable range, we would have gone ahead and obtained it. Does that answer your question?
Yes, sir. Thank you.
Okay, can we go to the second question?
Yes.
Can you read the second question for us? Prosper, since your mic is already open.
So the second question says, the sum of the second and third term of a geometric progression, GP, is 48. Is everyone listening?
We are. Remember, their mics are muted, so you will
Okay,
not
sir.
get responses.
Okay, sir. Then to continue, the sum of the fifth and sixth term is 1,296. Find the common ratio, the first term, and the sum of the first 12 terms of the GP.
Thank you very
Thank
much,
you.
Prosper. Let's first
Welcome.
hear from Vivi. Vivi has a hand up. Please go ahead and talk to us.
I want to take you through the number.
Oh, thank you very much, Vivi. Please go ahead.
As I have said, that the sum of the second and the third terms of a GP is 48. So that's going to be our first equation, where we shall have AR plus AR squared, which is equal to 48.
Let me see if I can write here.
Then they say
You said AR
plus AR is equal to 48.
AR squared equals
Is equal
48.
That's
Where is AR coming from? And where is AR squared coming from?
AR is our second. Since A, according to the formula of GPs, AR is our second term, and then AR squared is our third term.
Thank you very much. Where A is the first term and R is the common ratio. Please go ahead.
Then they have said that the sum of the fifth and the sixth term is 1296. So it's gonna be AR power 4 plus AR power 5 is equal to 1296. That's our equation 2.
1296.
Yes.
This
Should I
here is our second equation,
Yes.
meaning that our first is that one.
Yeah. So for
Good.
the first equation, we realize that we can factorize out AR, and then we remain with AR into 1 plus R is equal to 48. Should I continue?
Continue.
Then for the second equation, we can factorize out AR to power 4 and still remain with 1 plus R in brackets is equal to 1296.
Good.
So we are going to divide what we have factorized in our equation 2. We are going to divide it with equation 1.
So I'm going to have AR of 4
Into 1 plus R is
R
equal to 1000.
divided by
AR
AR
into
1
1 plus
plus R,
is equal to 48.
and this is 1 to 96
Yes.
divided by 48.
Yeah.
Good.
So our 1 plus R is going to cancel. Out, and our A will also cancel out. Then, according to indices, the 4 will subtract with the 1 and then remain with R cubed.
R cubed, which is equal to 1
Which
to
is equal to
96 out of, which is
48, 27.
gives us 27. Good.
So we find the cube root of 27. So our R is going to equal to 3.
R will be 3.
Yeah.
Very good.
So we substitute the 3 into our equation 1 to get the value of A.
When I go back to equation 1 and substitute the 3 for R, so I am going to get AR, which R is 3. Then I get
Yes.
1 plus 3, which
Yes.
gives me 48.
Yeah.
When I work out this, I think I'll get 12A, which is 48.
And our A is 4.
Our A will be 4.
Yes.
Good. Then go ahead.
But you're not sharing the screen.
Oh, how come
Yeah.
you never told me all along? I thought I was sharing. I'm sorry. I shared just a question.
Yeah.
Very, very sorry. Okay, let me share my screen. Is it there now?
Yes.
So
Yeah.
sorry. Can we go back then talk about what I've written to the listeners, to those who are tuned in? Just take them through again very fast.
Okay, they told us that the sum of the second and the third term is 48. So according to the formula of GP, that's what we use to get AR plus AR squared is equal to 48 to give us our equation 1. Then they say the fifth and the sixth term, the sum is equal to 1296. So AR4 plus AR5 is equal to 1296. But realize that in both equations, we can factorize them. So when we factorize the first equation, we are going to get AR into 1 plus R is equal to 48. Then when we factorize in the second equation, we are going to get AR power 4 plus into brackets 1 plus R is equal to 48. Then we shall divide the second equation by the first equation. Then we shall cancel out the common figures and then remain with R cubed is equal to 27. And the cube root of 27 is 3. So what you're going to do, you're just going to substitute our common ratio into the first equation and realize that you'll get our A as 4.
Thank you very much, Vivi. Then can we now go ahead and answer the questions? Do you still have the questions? What are the questions?
So they are saying we have already found the common ratio and the first term, and they're telling us to find the sum of the first 12 terms in the GP.
Okay. R is our common ratio. If we never defined it, then we can go ahead and answer that common ratio. Common ratio is 3. If we didn't define it, but at a certain point we could define that R is our common ratio. Then also so that it is clear. But this is some widely used thing, though I don't want us to take it for granted. Likewise, our first term. Usually first term can be denoted by U1, but still you can say our first term A is 4. Our first term A is 4. Then we are required to find the sum of the first 12 terms. We can go ahead and say sum of first 12 terms. Sum of first 12 terms. Sum of the first 12 terms, which is denoted S12, isn't it?
Yes.
S12. So S12 is what? So go ahead and find S12.
S12 is A into brackets R power n minus 1 out of R minus 1.
This is Sn, not so?
Yes.
Sum of n terms. So can you now make sum of 12 terms? What is the sum of 12 terms?
Yeah, we are going to substitute our
12 terms.
name because we know that our A is 4.
4.
And then our R is 3.
The
Power n, which is 12,
Mm.
minus 1.
Mm.
Of our R, which is 3, minus 1.
1.
Yes.
Okay. Whichever one can look for on a calculator to obtain the final value. What is our final value?
I'm getting 1,000. 62,880.
Okay, thank you very much. 880. We appreciate you, Vivienne. Not Vivi, sorry. May I request comments from our friends? Any comments from you? Question or supplement or compliment? What can I hear from the class, from the rest of us? Do we have any comments, members? I'm ready to take the comments. Do we have any comments from you? Any comments from the members here? If there are no comments, can we go to the next? Is everyone comfortable? We move to the next. Okay. It seems we are comfortable. Oh, Winnie, please say something. Winnie, please unmute and say something. Sorry, Winnie, unmute again. Okay.
I'm asking that there is here where we are always given a into brackets 1 plus r at power n out over 1 plus r. When do we have to apply that?
Winnie, did I get you? What was your question?
My question is that we have this other formula whereby instead of having r to power n minus 1 out over r minus 1, we use 1 plus r power n over 1 plus r. I don't know when do we have to apply it, because they do say that it should be applied when 1, like the value of r, is less than 1. So what if we apply it here? Can't it work? Is it a must that we have to apply it when r is less than 1?
Winnie, when you apply it, I think I get the question. If I have not got it, you help me to get it. When you apply, are you seeing my screen? No?
Yes.
My screen,
Yeah,
is it? Huh?
I'm
Have I
seeing
shared
it.
my screen?
Yes.
Oh. And what is my
Yes. Yes, your screen is shared, sir.
Okay. Now what is my challenge? I think I get my challenge. Thought I hadn't shared. I think I get the question. One, you are saying when do we apply? First and foremost, please take the equation properly. The equation should be A into 1 minus r at power n, not a plus, over 1 minus r. Not a plus, but a what? A minus. And people say, like you have said, we should use it when r is less than 1. And your question is, what if I use it when r is greater than 1? When you use it when r is greater than 1, you get the answer. The only challenge you'll find is that you're going to deal with negatives, which negatives, if you deal with them properly, you get the answer. I don't know whether that answers you, but that's how I get your question. Okay. So when you use it properly, no problem. You get the answer. Yes, any other? Winnie, still?
So if that answer has been gotten as a negative, can you just ignore the negative and you write it as a positive?
You will not get it as a negative value. You are working with the negatives, but you get the correct answer.
Oh, okay, sir.
Because you're going to get a negative divided by another negative. And at our age, we know very well that when I divide a negative with a negative, I'll come up with a correct answer. So do not just ignore. Work with it and work with it properly. You get the right answer.
Okay, sir. Thank you.
You're welcome. Okay, if there is no other challenge, can we go to the next number, which is number 3 in our work. Number 3 in our work is talking about number 3 in our work. I don't have to share that. I will just take this. Number 3 in our work simply tells us to use Okay, hope you are getting the question. And I think I already have a hand up from Joran. Joran, go ahead and unmute.
Okay, so I was asking of the previous question. When do we use the r to power n minus 1 and the 1 minus r to power n?
Joran, just a minute, just a moment.
Okay. All right. Yeah.
Oh, Joran, I'm sorry for that. But your question was talking about when do we use the r to power n in that formula of sum to n? And we had hinted about it. We said that when r is bigger than 1, it is easier to use r to power n minus 1 over r minus 1. But we can use any. There's no problem, only that we are looking at the other as easier depending. If r is smaller than n, it is easier to use 1 minus r to power n over 1 minus r into a. So it is only easier, but I can use any, and I will get there. So it doesn't mean the other doesn't work. I hope I'm making myself clear. Both work, but it is only easier.
Okay, yeah, thank you.
Good. Okay, I have already shared the number 3. I hope you're getting number 3. May I have someone to get? Joran, can you see my screen, number 3? Joran, can you see number 3? Oh, you have already muted. Please unmute and give me and tell me if you can see the answer, the question. Joran?
Yeah.
Can you read it for us?
Yeah, I'm on the track, sir.
Can you read the question for us? Number 3. Can you see it?
Yes, sir.
Please read it for us if you don't mind.
Okay, here I am. Use the Moivre's theorem to prove that cos 5 theta minus 16. No, sorry. Cos 5 theta is equals to 16 cos power 5 theta minus 20 cos power 3 theta plus 5 cos theta.
Thank you very, very much. Thank you, Joran.
Okay.
May I call upon anyone who would want to take us through this? If someone is ready to take us through, please put up your hand if you're ready. Put up your hand if you're ready to take us through. Winnie, unmute, please. Okay.
Yes. So for number 3, it's telling us that we use the Morpheus theorem to prove that cos 5 theta equals to 16 cos to power 5 theta minus 20 cos cubed theta, then plus 5 cos theta. So here we know that the Morpheus theorem states that cos theta plus I sin theta.
Can you state the Morpheus theorem? What does it state? Cos
theta plus I sin theta to power n is equal to, now when we add to power n equals to cos n theta plus I sin n theta so that's how it states, and whereby n is our power.
whereby n is?
Our power that we have been given, like the maximum angle there.
Okay.
And for this case, our n is a 5.
Okay.
So what we have to do, we shall have to write cos, like we replace the n with 5. So it will be cos theta.
Just a minute.
Okay.
Just a minute. Okay. Okay, go ahead now. I am ready.
Okay, so from how our theorem is stating, we shall have our n replaced with a 5. So it will be
I have
cos theta plus I sin theta.
I, the sine of theta, all of it to power 5. And this is equal to
So when
the
we reach here, we have
the cosine of 5 theta plus I, the sine of 5 theta. Is that what you want me to write? When I
yes,
replace the n with that. Please go ahead.
yeah, so that's how it will be. So when we come back here on this very first one, cos theta plus I sin theta to power 5, we shall have to expand it by normally. And from there, we shall even have to apply the Pascal's triangle. And so we shall have our cos theta plus I sin theta to power 5.
So our cos theta plus I sin theta to power 5
giving us
will give us
cos to power 5 theta
cos to power 5 theta.
plus,
when you expand using the binomial theorem,
and
plus
use plus 5 cos to power 4
cos to power 4 of theta,
sin I theta,
I, the sine
sin
of theta, yes,
plus 10
plus 10
cos to power 3 theta,
cos to power 3 theta,
I squared sin theta, sin squared theta,
I squared,
sin squared theta,
sine squared theta,
plus 10
then I'll have to add 10. Are you there?
yeah, plus 10 cos to power cos squared theta.
Or someone is asking if the sign with a isn't that sign with a negative? I think we are simplifying slowly by slowly. Let's wait and see where we are going. Yes,
Yeah.
cos to power 2
Yeah, cos to power 2
theta.
I cubed sin cubed theta.
Then this is I cubed. Oh, I have my issues there, writing slowly by slowly. So I cubed.
Sin cubed theta.
Sine cubed theta
plus 5
plus 5
cos
cos
theta
theta. Yes.
I to the power 4
I to the power 4
sin
sine
to the power 4 theta
power 4, and finally plus
I to the power 5 sin to the power 5 theta.
I to the power 5 sine power 5 of theta. Good.
So from there we are going to simplify, whereby the i's we have to eliminate some of them, and so we shall have our cos to the power 5 theta plus cos to the
Cos
power 5
power
theta
5 theta.
plus 5 cos to the power 4 theta I sin theta.
Do you mind? Okay, plus 5. There's an I there.
Yes.
Cos to the power 4 theta. Now I'm finding a little challenge writing. Stuffing is not smooth, but it's fine. I'm slow, so I want to skip some stages.
Yeah, by the way, I wanted to ask you, Master, that is it okay if we just skip some stages?
You should write most of them. That's what I can say. But
Okay.
for me, because it is a discussion, but you should write. They should connect. They should be able to connect. Someone should be able to understand you. If
All
you
right.
write something that does not connect to the previous one, then you leave someone suspicious of whether you have just copied it.
So we have to present them.
Present as, what would I say? What you're presenting should be connecting. A person should be able to read the first one and see that the second one comes from the first.
Okay, sir. So minus 10 cos cubed theta sin squared theta.
Minus 10 cos cubed theta
Sin squared theta.
sine squared theta.
Then minus 10i.
Minus 10i.
Yeah. Cos squared theta sin cubed
Cos
theta.
squared theta.
Sin cubed theta.
Sine cubed theta.
Then plus.
And plus
5 cos theta sin to power 4 theta.
5
cos theta
cos theta
sin to power 4 theta
sine to power 4 theta
minus I sin to power 5 theta.
minus
Sorry,
plus
plus,
I
yeah. Plus I,
power 5 theta.
yeah. So from here we have to collect the real and then the imaginary parts, we put
Good.
them together, yeah.
Good.
So
So
shall we cos 5 theta, I mean
cos 5 theta, which is the real part. Cos 5 theta equals to the real part on the other side. That's what you're saying?
Yeah,
That is the real
like
part.
you have, it is cos power 5 theta.
Cos power 5.
Theta plus Sorry, minus, it's minus 10 cos cubed theta.
Cos cubed theta. Sine. That's sine squared.
Yes.
You can't see it.
Yeah, you can't see it.
Okay. Can you see it now?
Yeah. So it is cos pi theta minus 10 cos cubed theta sine squared theta. Then plus 5
Plus 5 cos theta.
cos theta sine power 4 theta.
Sine power 4 of
Power
theta.
4 theta.
Yes.
So from here, wait. Oh, I'm really lost here.
Yes, what is the issue?
Like I'm getting lost here. Is it the question that I'm having wrong?
Okay, should I go to the question?
Yes, sir.
What did the question want? Cos of 5 theta equals to 16 cos to power 5 minus 20 cos cubed plus 5 cos theta. Does that now make
Okay.
sense?
Okay.
Mm-hmm.
Oh, so there I'm lost.
What is making you get lost?
Now the 16 cos to power. Okay. Let's see where the imaginary part.
Okay, can we get help from the class, from members? Anything that you're noticing that is challenging class? Anyone who would want to say something where we are? If you're following her, what is her challenge? When she says, should we now go to the imaginary part, is that the way we are going to get out of our challenge?
No, not like that.
No. How do we get
Yeah.
out of our challenge?
Oh.
Yes, we have two people with hands up. Who are these? One is the Winnie herself. Okay. The other is Olga. Olga, talk to us. Olga, unmute. Olga, unmute, please. Okay. Talk to us, Olga.
Good afternoon, everyone.
Good afternoon, Olga. These people are muted, so you'll not hear many of them answering you.
Yeah, I know. Well, I think we then go and find also sine 5 theta.
Sine
After
5
that,
theta.
yeah,
So you are
after
looking at equating the imaginary parts.
yeah, comparing real and imaginary parts.
Sure.
Yeah, I think that after she has like
Is
left that,
the imaginary part going to give us cos of 5 theta? Because what we are looking at in the question is this part of cos of 5 theta. I don't know whether you are
Sir,
noticing.
excuse me, sir.
We are here at the part of cos of 5 theta. Is the
Excuse me,
imaginary part going to give us cos of 5 theta?
no, sorry.
Master.
Mm.
Excuse me, sir.
You are excused.
Now from there,
Mm.
so we are going to express the sine squared
Yeah.
theta.
Our
Yeah.
issue is actually our work basically is in only cos.
Yeah,
So we
so
should get rid of the sine
that's
square,
sine.
isn't it? And the
Yes,
sine power 4. So that we create
yes,
our work in terms of cos and cos only. Okay?
yes.
So go
Yeah.
ahead and tell me where you find us.
So from there, we shall have our cos to power 5 theta.
Cos to power 5 theta.
Minus 10 cos cubed theta.
Minus 10 cos cubed theta.
And we know from our identity of cos squared theta plus sin squared theta equals to 1. So for this case, we shall have 1 minus cos squared theta.
For sine squared.
Yeah. Then plus 5 cos theta.
Plus
5 cos theta.
Plus 5 cos theta.
Sine squared
Plus
theta
5 cos theta.
Into 1.
Into 1 minus
cos
to power 2 of theta, all of it squared. Now, may I request that I give each one of you 2 minutes and you write 2 minutes, then you write that work up to the end. Let me, when you are done, put up your hand, and I want to see by show of hands. So may I request that everybody puts down their hands, work out, and then you put up your hands when you're done. Just 2 minutes.
Sir. Excuse me, sir. Sir.
Mark is done. Winnie, I don't know whether you are done or you never put down your hand.
No, like someone was saying that you scroll down.
Down where?
But I won't see the upper part. I mean up, scroll up.
So they never bothered. But what is important is not up there. What is important is to write this. I wanted everyone to write this part and complete it from where we are. You don't have to go back. But from where you are, can you write that part and complete it? I want to appreciate Yigamak is already there. Olga is there. Nwandinda is there. And Vivier is there. Vivier is there. When I'm waiting for your hand up, when you're already there.
I'm already there.
Wapi, your hand is down. When your
It
hand
is
is down, don't want to lie. It's up
it's
again.
up. Yes.
When you're just putting it up. I can see Dante. I see Isaac Lamek. I see Winnie. Yes, Winnie is there now. She says, I can see there's
She's now
someone who's
done.
she's not she's there, seriously there. Eh? Montes is there. Okay. I hope everyone can reach there. Thank you very much for that participation. Can you give me now the final? Now may I ask for the final? Your final. Those of you who are ready, I no longer see you. I don't know you are there. Iga, unmute and give me your final. Your final. Iga, where is Iga? Iga is. Oh, I'm missing you, Iga. Iga, please unmute. Iga. Okay. Iga, make your comments. Can you talk about how you moved and just tell us how comfortable you are? Iga? Iga, not Iga. Iga. Iga, is there?
Yes, I'm here.
Yes, can you talk about what you did and just tell us what you did. Talk about and tell us how comfortable you are.
I simplified the bracket.
Mm,
I put in this bracket the bag of prayer.
mm.
Then simplified this bracket. I tried to cut characteristic.
Okay, thank you, Iga. I can't hear you very well, but I got the fact that you simplified the brackets and got the... So did you get the final answer? Yes, by putting up your hand, you got the final answer. I hope everyone can reach the final answer. I want to suggest that we move to the next. Any comments in the comments column? Yes, in the comments column, Jocelyn is done, Raison is done, Prosper is done, Kusima finished, and I think I'm very happy with those comments. Who else? Who else? Someone was not happy at a certain time. KCS, or who is KCS? Then Epi was not there. I don't know where they were because Aiko, when we said that you try out, for you, you remained where? Isaac Lamek, done, finished. Angie wanted me to scroll. Okay, I think that is it. Those are the comments that I am getting. How did I disappear? That's Angeline. Angeline, remember we are comparing. The parts which have I are imaginary. My internet is not stable. I hope you can hear me. If you can't hear me, just use the hand up. It is the one thing that I can easily see. But I think I can unmute you if you are ready to behave. Some of you, when you hear the background noise, you mute. Huh? I think I should unmute you. I want to talk to you when you are making your comments. Someone wants to know how long the lesson is. Tracy, those are bad manners. But we are going for 2 hours, so we still have another 30 minutes. You don't have to worry. At 4, round 4, we shall close. Tito is done. And thank you, everyone. Good. Can we go to the next question? Can we have the next question? It is to do with integrate. That's question 4. It's to do with integrate. What are we integrating? What are we integrating? We are integrating. Look at our screen. Question 4. What is in question 4? Okay. Okay, let's go ahead. I'm looking at, we can go ahead and look at this work here. What is what? Okay. Yes, may I hear from all these people didn't put down their hands? Odravu SS. Odravu. May I unmute you? Odravu. Oh. Odravu, I'm finding a little bit of a challenge here. Don't worry, I'm going to unmute you. Odravu. Sorry about that. Okay. Let me first unmute Vivian. I have a little bit of a challenge here. My screen, why is it sensitive? Very sensitive. Okay, Odravu. Can you unmute now? Yes, say something.
Okay. Good afternoon, everyone.
Good afternoon to you.
Okay, I hope we are proceeding to the next question.
Yes, please.
Okay, I would like to take us through the next question.
Oh, thank you.
Yeah.
Thank you. Let me pick it and put it here. If I have picked it. Just a minute, I want to share the question.
Okay.
Okay. Okay, go ahead.
Okay, once more, I want to thank everyone for taking this initiative to attend this meeting or the seminar. And I want to take us through this question, which is all about, it is saying integrate x to power 3 out of root 1 plus x squared with respect to x. If you are to look at integration, this is I really look at the question and I try to understand it And if we say it is integration, that must be integrating with respect to x, but I tried to look at the question. I thought it was in this differentiation. Of course, when I look at this, and if you also look at this, it is where the derivative exists. So we have x to power 3, and we have root 1 plus x down here. This is the integration by parts. I am not wrong. I hope
Yes,
you
what
have.
is Honorable S.S., what is your name?
Sorry?
What is your name?
I'm called Mustafa.
Mustafa.
Yes.
Okay, Mustafa, please go ahead.
Let me hope you share us the screen.
Oh, you don't have the screen now. Thank you. Let me share the screen again. Do you have the screen?
No.
Not yet.
Yes.
Share this screen. You have the screen?
No.
Are you sure?
Yeah.
Okay. I think now I'm sharing. No screen yet?
Not yet.
What is on your screen?
I'm only seeing the question.
Oh, yes, that's what I've shared. What screen do you want?
Sorry?
What screen do you want?
Yeah, I wanted you to share the screen with the people so that you can be able to write something.
I have shared. When you tell me to write, I will write. I'm ready.
Okay.
Mm.
Okay. And in integration, if you are to look at what is in the denominator, and that is, I think it is tan substitution. Now, when you look at the denominator, you can be able to say this is you can be able to equate tan u or tan theta to what is there in the denominator.
So I should let tan theta equal to the square root or the 1 plus, which one should I take? The whole square root or the 1 plus x squared?
1 plus x squared.
The 1 plus x squared. Should I let the whole 1 plus x squared be tan theta?
Sorry?
What do you want tan theta to be? Mustafa. Mustafa, can you hear me? Mustafa, am I losing you? Yes, Mustafa? Mustafa, I'm waiting for you. Prosper, I want to say something.
Yeah, good afternoon, class.
Yes, good afternoon, Prosper.
Yeah, so maybe we get another person, but the question that I had. The question that I had, sir,
What is the question?
whenever they say integrate,
Hmm.
how can you differentiate that this one is used for sign substitution, time substitution? There is even the sec substitution, then the partial. About the partial, I can explain how it is. Now, these questions of integrating to differentiate them from these questions of sign substitution and tan arc substitution.
Okay, I've heard that question and I'm not going to answer it now. Let me hear from Douglas.
Okay, sir.
I've heard, just hold, keep waiting. I think if I forget, you remind me. Douglas?
Yes, good afternoon.
Yes, good afternoon, Douglas.
Yes, I have an alternative, but also simpler way of operating this question. Am I allowed to go? No, we can wait for whoever is presenting to complete first.
Okay, Douglas, you are ready to take us?
Yes, I'm ready.
Please go ahead.
So I'm going to use a formula called okay, all right. I'm going to use the U substitution formula. I hope that we are all familiar with the U substitution.
Please tell us what it looks like.
So for the U substitution, we are going to let the function of the integral be equal to U. So the function of this integral is going to be the root of 1 plus x squared. So we are going to say U will be equal to the root of 1 plus x squared. That's okay?
Fine.
Yes. So when you continue to work out this, we are going to have to first get rid of the root. So for our next step, we shall say u squared will be equal to 1 plus x squared.
Yes, please.
Very well then. So after this, one thing we should keep note of is that whenever we reach the u squared is equal to 1 plus x squared, we're going to differentiate. And when we differentiate u, we're going to get to u with respect to u. So it's going to be to u du. Then will be equal to, when you differentiate 1.
When you differentiate, what are you getting?
When you differentiate u, you're going to get to u du. Because we are differentiating with
Douglas, you are leaving me at that point. What you are getting is not clear for me.
We are going to differentiate u squared.
What do we get?
We're going to bring these two down and
so what should we get?
It's going to be 2u.
It will be
2, then
2
u.
Yes.
And we are differentiating with respect to u. So this will become du. So we're going to multiply this to u times du.
Du.
Is that okay?
Go ahead.
Okay. Then when we differentiate 1 plus x squared, when you differentiate 1, you get 0. Then when you differentiate x squared, you get x dx, because we are differentiating this with respect to x.
We are getting 2
x
dx.
Okay. So we are going to substitute. Sorry, we are going to find out the value of dx. So that when we are substituting, we can substitute in the formula. So according to this function that we have here, dx is going to be equal to 2u is equal to 2u du over 2x. I hope we all see where that is coming.
Yes.
Okay, all right.
When we have issues, we shall put up hands.
All right.
It's what I can hear. I am not following so much of the chat because I'm writing, but I can see the hands up. So when I see no hands up, I take it that we are still moving together.
All right, okay. So we are going to come down and we are going to rewrite our integral. So this is going to be the integral of x cubed x cubed, yes, over x cubed over root of 1 plus x squared.
We are rewriting, or we are writing the other what we had?
We are rewriting so that we can equate and substitute.
Okay, over 1 plus that one.
Squared dx.
Yes.
Is equals to the integral of x cubed over u. Remember, u is equals to root of 1 plus x squared.
Over u, because the whole of this is the u.
Yes. Times.
Multiplied by.
Yes. Remember our dx, and that is to u du over 2x.
2u du.
Yes.
Over 2x.
Yes. That's substituting for the dx. So if you look into this, this formula that we have here, you see that this x can cancel out with one of the x's in x cubed. And this u can also cancel out with the u.
So the u will cancel with the u.
Yes, the x can cancel with the
cancel out one of the x's.
Yes, and the 2 can also cancel out.
And the 2 will also cancel out.
Yes. So we shall remain with.
Let me see, there's a message in the. Okay, the messages in the messages that we have are allowing you to continue. They are following.
All right.
Thank you for that positive
all right.
Message. Yes.
Very well then. So we remain with x to the power 2.
We are remaining with x to power 2.
du.
Du.
So what does this, allow me explain this, please.
Please go ahead.
So what does this du mean? This du simply means that our integral is in respect to u. And here we do not have integrals where we can change. So we don't have the limits where we can change the variables. So what are we going to do? We are going to go back where we have u squared is equals to 1 plus
to
x.
Go back to this level.
Yes, so we are going to make x squared we're going to make x squared the subject so that we can find the value of x squared in terms of u, whereby we shall then substitute the value that we get. So we are going to get, that is, that we get, I think, u squared minus 1. U squared minus 1. So this value that we've gotten here, we're going to substitute it into this function.
Okay.
Yes. U squared minus 1 du. So we have our whole equation with respect to u. So you just simply integrate this, that gives you u cubed, a third u cubed minus, minus u plus c. That becomes our final answer. Thank you.
Thank you very much.
You're welcome.
Why are you calling it our final answer? Are you forgetting that our original expressions are supposed to be in terms of x?
Oh, sorry, I forgot. We then remember our u is equals to, I don't know how I miscalculated that one. So our u is going to be equal to the root of 1 plus x squared. We just simply substitute and that becomes the actual final answer.
Okay. So put back our x because originally we had x.
Yes,
and it will give us 1 over 3. The u is 1 plus x squared, if I have not forgotten, square root, which square root is now raised to power 3. So I can write it as 3 over 2, or I can write square root to power 3, no problem. minus the u is still the square root of 1 plus x squared, and then plus c. Wow, thank you very much.
You're welcome. No problem at all.
Thank you. I think I love that. Let's get our comments from the comments column. From the comments column, what do we have? 3 messages. Thanks, Douglas. Thanks. Prosper, are you there? I don't know if Prosper is there, but I can appreciate. Thank you for appreciating. I can see thank you, Douglas. Thank you, thank you. Okay, good. Good. Thanks. I think those are the messages that we are having. Thanks. Okay, thank you for appreciating, guys. I can see here Douglas with a smile, and I can see the thank you from Joran, and Prosper is also there. Good, very good. Kale, can we now look at our next, which could be our final, maybe? Do we take that next as our final? And we look at that last one, number 5. Number 5 is having vector work. Number 5 has vector work. You forgive us, sometimes these discussions are a little slow. Winnie, you have a hand up. I can see Tito, thank you, I got it. Tito, thank you for appreciating. But where is Winnie's hand now? Can see Winnie has a hand up. Winnie, where's the... Okay, just a moment. I want to copy this work here. Then we can move. I'll come to Winnie's hand. Okay, I want to copy this work here, then we shall go back and pick Winnie. Where is Winnie now? Winnie, are you with us? Not yet. Okay. Winnie. Sometimes my thing is this disturbs me and I wonder why. Very sensitive. Okay, Winnie, unmute. Unmute and talk to us. Winnie? Winnie, unmute. Winnie, can you open your mic?
It had still failed, Master, so that's why I had delayed. It was like you're not accepting.
Sorry.
So I was requesting that as Prosper had requested you, can you please first help us before we go to the final answer?
Oh, what did you remember what Prosper said?
Yeah, like
Prosper talked about how do you know how to handle the different integration, whatever. Now, if you went to your book, especially Backhouse 2, you will notice that Backhouse categorizes our integrals. The first is the general one, where we are integrating the powers. The first is the general one, where we are integrating powers of x or powers of t. If I'm given t squared plus 5t minus 7, and this is all it integrates with respect to t. That's our general simple integration, where we are integrating term by term when we are looking at polynomials, when we are looking at a number of terms. And we are looking at our general rule of increase the power by 1 and divide by the new power for each of the terms. That one is our starting point. But then from there, the books take us, and of course, yes, they teach us the trigonometry also as well, the general. So you get used also to the general trigonometry. What is the integral of the sine? What is the integral of the cosine? What is the integral general? So you integrate generally, cosine, sine, and so on and so forth. Then where do we go? When you are used to the trigonometry and to the powers of x or powers of t or powers of whatever the function could be, then the simple categories that Backhouse gives us and which we should look for when you go to a paper. The first one is where we are looking at function and derivative. Personally, when I find an integral that is not the ordinary, I'll check, is it function and derivative? Where I have those powers, is it function and derivative? I have function and derivative in very many different forms. You will see function and derivative of this nature, where you are having function and derivative of which nature? Where you are having, for example, x squared. Oh, it can even be 2x squared minus 3. But then that one is raised to power. That one is raised to maybe to power 4. And you are supposed to integrate. But somewhere you have an x. Somewhere you have an x. And you are supposed to integrate this. And you are looking at the derivative of this function. I had Douglas using function. The derivative of this function is sum 4x. And when I have this x somewhere there, I notice that it is part of the derivative. The 4 is lacking, but the 4 is a constant. And when what is lacking is a constant, I can always bring it in the work. Constants are comfortable. You can always bring them in or out. You can always introduce them, and you can always factor them out. That's the beauty of constants. But the variable x cannot be introduced, and it cannot be factored out. So that is for the variables. So please, when it comes to those, you look out, is it function and derivative? And it should be your first question. I have seen it in terms of where I have cos to power if I'm to integrate. And what am I integrating? I'm integrating the cos to power 3 of x dx. But as long as somewhere I have sine x, then I'm taking this as the function, the sine as the derivative. The cos, which is raised to some power, is the function. Cos is the function, sine is the derivative function, and its derivative. That's the issue. Then I am looking at, what else am I looking at? I'm looking at, okay, all those forms, function and derivative, they appear in very many ways. It can be out of, someone has x somewhere, but it is out of some 4x squared minus 7 or plus 5, and you are integrating. And you can see that the derivative of this bottom thing is somehow, it is 8x, but the x is there. The 8 is the constant, is the only one that is not there. Function and derivative. Function and derivative can also appear in terms of e. You see e to power sine x, but e to power sine x integral, but it has a cos somewhere where the function is this one, the cosine is the derivative. So there are forms of that nature, which is function and derivative. So function and derivative appears in very, very many forms. Okay, now if it is not that one, what other technique do we know? The techniques that we have also include the techniques that we have also include the sign substitution. When we have sign substitution, usually it is a constant, and then I have the square root, and then I have another constant minus some x squared. When we are looking at our work, we are mainly looking at I'm integrating. I am interested so much in 1 minus x squared. So when I have it like 2, the 2 I will factor out. It is my duty to factor out the rest of the work and I remain with 1. When I factor out the 2, I remain with 1 minus x squared over 2. And when I have square root on each of these, then it will give me the square root of 2, and it will give me the square root of 1 minus the x over the root of 2, all of it squared. The issue is that it is, of course, I know I have a 5 somewhere up there. I know all that kind of thing. But my issue is mainly, I'm concentrating mainly on this. It is 1 minus what? So when I have 1 minus the x out of the root of 2, but all this is squared. Must be squared. But there's also a root somewhere out this way. This bracketed worker here, this worker in brackets, that is sign substitution. And the x over root 2 in brackets is what you let to be your sign of the angle. I heard someone talking about sine theta or sine u or whatever it is. But that bracketed work, but it should be 1, then it should be a minus, and then it should be something squared. That squared worker there is the sign. What is our interest? Our interest is that when you make it the sign, then you will have that this work of yours will become 1 minus sine squared. That's why you are making it sine. Then which becomes cos squared. Then which becomes the square root of which will become cos. And somewhere, even in your work, the dx will have a cos u, which is going to behave, and you'll have good work. So get used to the technique where I have a constant out of the square root of 1 minus something squared, bringing you to sign substitution. Then a constant, it can be a constant plus, but there is a squared x there, for instance. It should also be under some constant value here. And I'm integrating. What does it tell me? I can factorize out the 5, remain with 1 plus 2x squared over 5. This 2x squared over 5 can be root 2. Then it can be root 5. Then all this is squared. Your angle here, your angle there is the tan substitute, is the tan of the angle. So there is sign substitution. There is also tan substitution. But we also have other substitutions that can simplify the work, which may not necessarily be sine or tan. And if you look out for examples, you will see examples of the nature where it may not necessarily be sine and whatever. I can even have x and I have square root x, then I have the square root of, then I have 1 plus x. It is not function and its derivative. But I should be able to look out for a substitution that simplifies the work. That is where the change of variable is important. Simply change the variable and see where the variable leads, the change of variable leads you. If I took, for instance, my u to be the square root of 1 plus x, the same way Douglas has handled what the previous case. You will notice that you can choose to have u squared, which is 1 plus x, and you substitute into this work, make x the subject, which gives you u squared minus 1. Get the dx du, which will give you 2u. And also substitute for everything. So when I substitute for the x here, which is u squared minus 1, substitute for the square root of 1 plus x, which is u, substitute for dx, which is 2u. This was dx du, sorry, which is 2u du. Then you notice that the expression that comes out of this is easy to handle. And like the other one, which had the square root, and you could hardly open, because when it has a square root, you can't open. But here now you can open and simplify. The u squared times the u times the 2u will give you 2 u to power 4 minus 2 u squared, which is very easy to integrate. So there is also that change of variable, which can simplify your expression, which may not necessarily be sine or tan substitution or any other, but can simplify the expression that you are given. That's another technique. Then the other techniques that you have are those ones now where you can, you have things to do with where you can integrate natural logarithms. You have things to do with where you can integrate exponential functions. You have things to do where you, with the integration, you have by parts, where you are handling products that are not necessarily, this is a product by parts, we are having a product which is not function and derivative. Usually function and derivative is a product. But by parts, you will find yourself handling issues which are not function and derivative. So you are also going to look at this kind of thing and check your function and see, is it a product? Is it function and derivative or another product? And you require to deal with products where you are dealing with the u dv dx, that kind of thing. One is the u, the other is the derivative, which is not the derivative of u, but then you can deal with the integration of such in the form of uv minus integral v du dx. There are those things. Is it by parts? And so those are usually our issues. There are different techniques. There is also where you can split the numerator. There is also where you can, apart from splitting the numerator, what else can be? Anyway, which takes you to the other forms. Because when you split the numerator, then it takes you back to the forms of function and derivative, all that kind of thing. So there is that bit of it. Look at the techniques that you have. There are not very many techniques, but get used to them. Did I talk of partial fractions? I think I did. There's also partial fractions. Then also go to the trigonometry, even powers of cos and sine. How do I handle the even powers of cos and sine? How do I handle the odd powers? When I have cos squared, how do I handle? Those are even powers where you are using the double angle formula. How do I handle the odd powers? If I have sine cubed, how do I handle? Here where you are using the splitting, which brings you to the sine of x, then the sine squared, which sine squared is now changed into the terms of cos. Then when you change it, you produce a function and derivative, and that like. So look at the different techniques so that when you come to integrate something, you look out and check, is it function and derivative? Is it odd power of cos? Is it even power of cos? Is it sine substitution? Is it tan substitution? Is it by partial fractions? Partial fractions, please take watch. Before you break down any expression and resolve it into partial fraction, it must be proper. The moment it is improper, first use your long division technique to break it down into a whole something and a fraction so that you handle partial fractions of the other proper function. So look through and see, is it by parts? Those are the different techniques that we have, and you should be able to deal with the different techniques. It is your duty to look out out and see where your work belongs. Does it belong to this? Does it belong to the other? Yes, Elisha, please unmute and give us and say something. Make your comment. Elisha? Elisha, unmute before we close. Unmute, Elisha. Yes, Elisha.
Good afternoon, sir.
Good afternoon, Elisha. Yes, please go ahead. I can hear you. The class can hear. Elisha, have we lost you? I see you, but I can't hear anything. Network? Okay. Can we have anyone? Does anyone have anything to say before we close? Elisha, we can't get you. Sorry. Anything that you wanted to say before we close? Yes, unmute. I can see hands up. Please unmute. Prosper. Atkunda, go ahead. Atkunda had unmuted.
Yes, sir.
Elisha?
Yes, I had time to speak about the next number.
Oh, you wanted to say something about the next number.
Yes.
If there's nothing more, okay, go ahead because then the network may not favor us. Go ahead, please.
Okay. If we follow the question, they are saying the point A, B, C, D have position vectors given. Then they are saying show that A, B, C are collinear. Then state the ratio. So according to my approach, if we have A, B,
So you can get a B.
yeah, it comes from, so is equals to OB minus OA.
This is
The same as 5P
minus Q
minus Q. Then
minus 2P.
minus 5P.
Very good. Go ahead. What does it
Then
simplify it to?
it gives us a product of 3p
3p
plus then 4q.
then plus 4q.
Then if we see another combination of BC, which comes from O minus C.
Go ahead.
And which has a product of the value of 11p and 7q
Yes.
minus 5p then minus q.
Which finally gives us
6p then 8q.
Then this one will be positive.
Yes,
So
please.
from there, if I factorize out 2 on that product of BC, I see that I get 2 into.
You forgive me that my BC was at the bottom of the page, so I can't keep with it. But the BC is 2 into
3p
3p
then 4
plus 4q.
Yes. So
Good.
the product in the brackets it is showing us that it is the same as that of AB.
So we can comfortably say that BC is twice of AB.
Yes. So to get the ratio.
Before that, what conclusion do we get it out of here?
So we shall say there are 4. The lines AB
and BC, the vectors, are parallel.
According, yes.
AB and BC vectors are parallel. But since B, when you have parallel vectors, but B is common to both vectors, B is a common point, then it shows you that the points, since B is a common point of the vectors, we are now looking at the vectors. Since B is a common point of the vectors, then we can comfortably say the vectors AB, the points A, B, and C are collinear. Please make sure that you are strong on your conclusion. Make sure that you are strong on your conclusion. Do not just conclude, but make sure you are strong on your conclusion.
Okay, Master.
Okay. Go ahead, please.
So to get the ratio, I'll get the product of AB.
You get the vector AB. It's not a product.
Yes. Divide by the vector BC.
Good. Which is already clear.
Yes.
Should I write this again? 3p plus 4q.
Then
And should
over
I write the 2
into
plus 4q, isn't it?
4q. Yes.
And you'll have that this is 1
1
over
over
2. So the AB to BC ratio
equals to 1 to 2.
Equals to 1 to 2. The AB to BC ratio is 1 to 2. Thank you very much.
Yes,
thanks,
you. Sir. Welcome.
Thank you so much. Okay, can we have any comments before we close? May I give my last remarks? May I give my last remarks, please? Are you saying something before? I have seen in the chats, I see people who are grateful. Thank you. Thank you very much. See, one thing to appreciate is another. Thank you very much. Okay, as my last remarks, I want to thank you very much for attending, coming. I want to thank very much Mr. Dungu and Mr. Dungu Ronald and Mr. Kaziba Stephen, who are giving us this platform for where we can share. I thank you very much for participating. You did not only attend, but you came ready to participate by answering questions, by asking questions, by providing whatever that you could provide that was necessary to help another. Thank you so much for that. So I appreciate you. I want to thank our parents who provide for us, because you all know that for us to be able to share, we must be connected. We must connect. So we thank the parents. I want to thank the schools that have given you the opportunity. I want to thank also the teachers who have guided us, who have also encouraged us to attend, and they have also given us, the schools have given us somehow they have helped us to connect. Schools give us the data, they work like parents. Please, when you meet all those, thank them very, very much. I'll please go to the WhatsApp group. The questions are there. I can also share them again that side. With our WhatsApp group, I think you will get those questions there, so that you try and see and check yourself. You can actually always give yourself more. Mr. Kaziba will also give us other questions. Can I have the link? Someone is telling me to give the link. Is it possible for me to share the link here? Oh my God, I would be very grateful if I can. Let me see if I can share the link. Where is the link? Can I get the link here? So thank you very much. Okay, as I look for the link, can I ask for a volunteer? A volunteer, as I try to get the link. Can someone now lead us in a closing prayer? Please lead us in a closing prayer. Do we have someone who is ready to lead us in a closing prayer? Anyone ready? Who is that? What you do, take my number, then I can connect you to the WhatsApp group. So you write, my number is 0783. My number is 0783 24 6050. 0783 24 6050. So you can send me a WhatsApp message, then I'll be able to connect you to the WhatsApp group, where you can find all kinds of communications that you may find. There are also a number of questions and so on. Tito, are you ready to pray for us, Tito, please, so that we don't just move, but we go with
Chuck, can you resend the questions? The
I'm going to
questions that you
send
have done.
we are going to share them on the WhatsApp group. So I've told you, send me a message. I'll share with you. I'm giving you my WhatsApp number, please. Okay. Okay.
Yes.
Can I have a prayer, please? I have two hands up. Angelina? Angeline? Angeline, are you leading us in a prayer so that we don't just go? Okay, Winnie.
So let us pray. Heavenly Father, in the mighty name of our Lord Jesus Christ, we humble ourselves before you this evening. We thank you for the gift of life that you've given us, Lord King of Glory. We thank you for this service. We thank you that we have grasped something from what the teacher has taught us. May you bless him and may you bless those ones who have sponsored it. We pray that you be with us and you help us to prosper this year. We may get good grades that will push us to the next level of education. In the mighty name of our Lord Jesus Christ, I have prayed and as I believe. Amen.
Naye
Amen.
Tito is telling me the
Yeah.
microphone, but Tito. Okay, thank you very much. I want to wish you a good evening.
Good
Bye-bye.
evening. Bye.
You can open
Bye.
your videos. Those of
Bye.
you,
Bye, teacher.
those of you
Bye,
who
teacher.
want to open your videos, you can now open the videos
Bye.
and say bye. Yes,
Bye.
you can open the videos and say bye. I'm not seeing you.
Thank you, sir, for the number.
Where are you?
Bye, teacher. Ping.